Hey guys, this is Dr. Rishi from the Learners Academy, and today we are going to talk about rational numbers. In the previous videos, we have talked about natural numbers and whole numbers. Today, we take this one step ahead and we would be talking about rational numbers. Now, I have skipped the video on integers because integers are pretty much somewhat similar to whole numbers and natural numbers, except with a negative sign in them. So we have the negative numbers included. I feel this particular video is very important because this is taught in standard 8th ICSE and CBSE. So let us go ahead and talk about what rational numbers are. In this video, we are going to see what rational numbers are, operations on rational numbers, and their use in real life. We are also going to study properties of rational numbers, what they're named, and how properties of rational numbers and their names. So without losing any time, let's go ahead and talk about rational numbers. So by definition, rational numbers is a number that can be defined as P upon Q. That is, anything that I can write as P upon Q that has a numerator and a denominator is called as a rational number, where this denominator cannot be equal to 0. So we have a numerator and a denominator. The top part is numerator, the bottom part is denominator, and the denominator can't be 0. Rational numbers are written in the form of P upon Q, so we include all the fractions and all the decimals, and the denominator is not equal to 0. We call such a number as rational number. If a number is not rational, then we will be calling it as an irrational number. So anything that cannot be written in the form of P upon Q, where Q is not equal to 0, would be considered as an irrational number. These are very special kind of numbers that we have. We would be dealing with irrational numbers in a separate video. So today, let us stick to the topic, that is rational numbers. So let us see what rational numbers are. Every natural number, every whole number, every integer, and every fraction is a rational number, including 0, because 0 can also be written in this form. I can write it as say 0 upon 1 or 0 upon 2 or 0 upon 5 or 0 upon 3694. All these would be equal to 0 and they would also be rational numbers. These are the things that you should know when we are going to talk about rational numbers. Okay, first thing we already discussed, that it would include integers, whole numbers, natural numbers, 0, and all the fractions. The next thing that we have is, if the numerator and the denominator would have same signs, then the rational number would be positive. If one of the two has a negative sign, then that rational number would be negative. Okay, so positive rational numbers, both the signs are same. So if it's negative, P and Q both are negative. If it's positive, P and Q both are positive. Then that rational number would be positive. If P and Q both, one of the P and Q or Q is negative, then the rational number would be negative. Now, no matter what happens, if the numerator has a negative sign or the denominator has a negative sign, we generally keep the sign with the numerator only. Now, the next thing that we have is, if we have a number m which is not 0, and if you multiply that m with the numerator and the denominator, then the answer that we get is again a rational number. So if I have a number m which is not equal to 0, then P multiplied by m upon Q multiplied by m would be a rational number as well. Also, if I divide P by m and Q by m, the final answer would still be a rational number. That is, if I have P divided by M and Q divided by M. So these two numbers that I get after multiplying by M or dividing by M are going to be rational numbers, and they are going to be equal to P upon Q, which means if you have a rational number, you multiply or divide numerator and denominator both by same number, then the final answer would not actually change. So P upon Q would remain exactly the same even in this case or in this case. Now, the next thing that we should also know is, if I have two rational numbers, A upon B and C upon D, and they are equal to each other, that is A upon B is equal to C upon D, then in this scenario, A multiplied by D will be equal to B multiplied by C. That is, if I cross multiply them, I take the multiplication of these two, it should remain exactly the same. So moreover, we can change them and we can shuffle them and write it as A upon C would be equal to B upon D. So these two rational numbers and these two rational numbers are going to be exactly the same. Also, we can compare rational numbers using this property. So if I have A upon B is greater than C upon D, it would mean that A multiplied by D should be greater than C multiplied by B, and if A upon B is less than C upon D, then in that case A multiplied by D would be less than C multiplied by B. So by using this, we can clearly compare the rational numbers as well. Now let us quickly jump to the standard forms of rational numbers. So what are these standard forms? A standard form of a rational number is, we take the numerator and the denominator and we check if they have any common factors. In case they have any common factors, we would cancel those common factors out, and we would have two numbers which have only one common divisor, and that would be 1. So we follow two rules when we talk about standard form of rational numbers. The first rule is, there shouldn't be any common factor between P and Q apart from number 1, and the denominator would always be written as a positive number. So if I have 3 upon 6, then I can write it as 1 multiplied by 3 upon 2 multiplied by 3. 3's get cancelled and I have 1 upon 2. So this would be the standard form of 3 upon 6. Now if we go ahead and we check out the negative sign and I write something like minus 9 upon 12. Alright, let's have it as 9 upon minus 12. Then the first thing I'll do is I'll take the common factors. So it is 3 multiplied by 3 upon 3 multiplied by 4 with a minus sign on 3. One of the 3's gets cancelled and I'm left with 3 upon 4. Now since the minus sign is in the denominator, but in the standard form, the minus sign should always go to the numerator, giving me a minus 3 upon 4. So this is the standard form of a rational number. Now let us talk about operations and rational numbers. We are going to talk about 4 operations, that are addition, subtraction, multiplication and division. Let us first talk about the properties of addition of rational numbers. However, before we go ahead with properties, let us see how we do addition of rational numbers. So it's a crucial thing that since a rational number is a fraction, we are always going to check out the denominators. So first thing, let us understand how we add fractions, and then we go ahead and see the properties of addition of rational numbers. So in case I have 3 upon 4 and I have to add 2 upon 3 to it, I cannot add it or subtract it unless and until the denominators are same. So the first thing Now, there is a detailed video on addition, subtraction, multiplication and division of fractions. The link is given up here. Please click on it in case you feel confused. The link is also given in the description box. So in case you miss out on this link, please click in the description box. Now, so let us see what we do here. It's 3. So since the denominators are 4 and 3, I have to make the denominators same. So the LCM of 4 and 3 is 12. So to make this 4 into 12, I'll have to multiply the numerator and the denominator by 3. And in this case, I will have to multiply it by 4, giving me my final answer as 9 upon 12 plus 8 upon 12, which would be 17 upon 12. So this is how we add rational numbers if they are a fraction, if they have a denominator other than 1. If the denominator is 1, we don't have to worry about it, because then we can go ahead and add them directly. So the first property that we study is closure property. Closure property, as we have discussed earlier, tells us that if you add two rational numbers, then the final addition is also a rational number, telling us that if we have, say, a upon b plus c upon d, then the final answer would be a rational number. Yes, so let us take an example on it. So if I have 3 upon 4 plus 2 upon 3, it's exactly the same example that we took prior to this. We can write it as 9 upon 12 plus 8 upon 12, giving me the final answer as 17 upon 12, which also is a rational number. Now, if we add a negative number, let's see what happens. If I have 3 upon 5 plus 2 upon 7, then I'll have to make the denominator same. So it would be 21 upon 35 plus 10 upon 35, giving me 31 upon 35. Let's take an example with a negative number now. So say if I have 3 upon 4, let's have a minus 3 upon 4 plus let's have 2 upon 5, then I can write it as minus 15 upon 20 plus 8 upon 20. Now since there is a negative number here and a positive number here, since they don't have the same sign, I would be subtracting them, giving me a minus 7 upon 20, which would be my final answer. So in all the three cases, what do we see? The final answer that we get is a rational number. Now let's go ahead with the next property, that is the commutative property or commutativity. Now commutativity basically tells us that if you take two rational numbers and you add it in a particular order, and if you reverse the order, the final answer remains exactly the same. That is, if I have a upon b plus c upon d, then it should be equal to c upon d plus a upon b. Now let's check it out with an example. So if I have 4 upon 5 plus 2 upon 6, and then the first thing that I'll do is I'll convert them into the standard forms. So this can be written as 4 upon 5 plus 1 upon 3. Then to add it, I'll have to make the denominator same. So it would be 12 upon 15 plus 5 upon 15, giving me 17 upon 15. Now, if I add it the other way around, what happens? So I'll directly take the standard form for 2 upon 6, that is 1 upon 3 plus 4 upon 5, giving me 5 upon 15 plus 12 upon 15, giving me 17 upon 15. So if you see, in both the cases, the answer remains exactly the same. This property is called as commutativity. Okay guys, so let us go ahead with the next property, that is associativity of rational numbers. Now what does associativity mean? If you add three numbers and group them in separate groups, the final addition should also be the same. Meaning, if I have A upon B plus C upon D plus E upon F, if I add these like this in the first case and I make it A upon B plus C upon D plus E upon F, and I add it in, I group them like this in the second way. In both the cases, the final answer should be same. It is pretty logical, makes sense. So let us see whether it actually works. So I have, say, 2 upon 3 plus 3 upon 4 plus 4 upon 5. It's a pretty interesting, simple thing that I have put here. So let's have it as, let's add them and see what we get. So first I have to add these together. So that would be 8 upon 12 plus 9 upon 12 plus 4 upon 5, giving me 17 upon 12 plus 4 upon 5, which would be equal to 85 upon 60 plus 48 upon 60, giving the final answer as 133 upon 60. Now, if you add it in this manner, let us see what happens. We would have 2 upon 3 plus 3 upon 4 plus 4 upon 5. So first thing I would get is 2 upon 3 plus, so I'd have 15 upon 20 plus 16 upon 20, giving me 2 upon 3 plus 31 upon 20. I cross multiply it again and I add it. It would be 40 upon 60 plus 91 upon 93 upon 60, giving the final answer as 133 upon 60. So if you see, in both the cases we got exactly the same answer. So you take rational numbers, you group them separately, you add them up, the final answer would remain the same. This property is called as associativity. Now let's go ahead with the next property, that is existence of additive inverse. So what do we mean by existence of additive inverse? There is a number which would exist, and if it is added to the given rational number, then the final answer would be equal to 0. So now the next property that we are going to talk about is additive identity. Additive identity is a number which would, if added to the given rational number, would not change the value of the rational number. Additive identity is 0. So if you take a number a upon b and add a number 0 to it, the answer would be equal to a upon b. So 0 in this case is called as additive identity. The next thing that we talk about is the additive inverse. Additive inverse is a rational number which if added to the given rational number, would give the final answer as 0. So if I have a upon b, then the additive identity for a upon b, the additive inverse for a upon b would be minus a upon b. So if I add a upon b and minus a upon b, my final answer would be equal to 0. If minus c upon b, c upon d is my number, then for that the additive inverse would be c upon d, giving the final answer as 0. So what would be the additive inverse for any rational number? All you have to do is just put a minus sign to the numerator. It would be the same number with a minus sign to the numerator. The sum, so effectively we can say that the sum of the rational number and its additive inverse would be equal to the additive identity. Now let's go ahead and check out the next operation, that is subtraction of rational numbers. Now addition and subtraction are somewhat similar when it comes to doing the actual addition or subtraction. That is, the denominators need to be same. So let us talk about it, let us solve a simple example and see what we have to do when we have to subtract two rational numbers. So if I have say 3 upon 5 and I subtract 2 upon 3 from it, then my answer would be 9 upon 15 minus 10 upon 15, giving me the answer as minus 1 upon 15. So the first thing I did is I made the denominator same, and then only I went ahead and did the subtraction. In case you find this difficult, please check out the link in the description which talks about a video on subtraction of fractions. Now let us go ahead and talk about various properties that are associated with subtraction of rational numbers. The first property that we talk about is the closure property. So if you take two rational numbers and you subtract them, then the final answer would be a rational number. So let us take an example, or we saw it in the previous example as well. When we subtracted the two numbers, the final answer was a rational number. So if I have say 3 upon 4 minus 2 upon 3, then the answer would be 9 upon 12 minus 8 upon 12, giving the answer as 1 upon 12, which also is a rational number. So we say that subtraction of rational numbers follows the closure property, or subtraction of rational numbers is closed. Let us go ahead to the next property, that is commutative property. Let us see if rational numbers are commutative or not. So if you take say 3 upon 4 minus 2 upon 3, we'd get 9 upon 12 minus 8 upon 12, giving me the answer as minus 1, giving me the final answer as 1 upon 12. Now what happens if we change the order? Because when we talk about commutativity, it is about changing the order in which we do the certain operation. So in this case, it would be 2 upon 3 minus 3 upon 4, giving me 8 upon 12 minus 9 upon 12, which would be equal to minus 1 upon 12. So now if you see, this side is not equal to this side, which means that subtraction is not commutative, which would, so we can write it in a formula form saying that a upon b plus a upon b minus c upon d is not equal to c upon d minus a upon b. So this was the commutative property telling us that subtraction of rational numbers is non-commutative. Let us go ahead with the next property, that is the associative property. As we have done with the associative property for addition, we are going to do the same thing here. That is, we are going to group them separately and then do the subtraction. So let us see what happens when we check associativity of the subtraction of rational numbers. So if I have 2 upon 3 minus 3 upon 4, so I'll take the same example to see the differences that we get, or if whether it remains the same. So it would be 2 upon 3 minus 3 upon 4 minus 4 upon 5, and I'll see whether the second part I'll have it as 2 upon 3 minus 3 upon 4 minus 4 upon 5, where I'll group these together. So in this case, in the previous case for addition, it was same. Now let us see what happens in this case. Here I have, so this would be 8 upon 12 minus 9 upon 12 minus 4 upon 5, giving me minus 1 upon 12 minus 4 upon 5, which would be equal to minus 5 upon 60 minus 48 upon 60, giving the final answer as minus 53 upon 60. So you see, through and through the final answer remains negative. Now let's see what happens in this case. I have 2 upon 3 minus So it would be 15 upon 20 minus 16 upon 20, giving me 2 upon 3 minus 1 upon 20. Now there is a minus sign outside the bracket, minus sign inside the bracket, so I will have to do the addition. The signs would change, so it would be 1 upon 20, giving me the answer as 40 upon 60 plus 3 upon 60, giving the final answer as 43 upon 60. Now you can clearly see that both the answers are not equal, which means that subtraction is not associative as well. So let us see, let us put it in a formula form, saying that a upon b plus a upon b minus c upon d minus c upon f grouped like this will not be equal to a upon b minus c upon d minus e upon f grouped like this. So when we do subtraction of rational numbers, we have to keep the order in our minds. We have to also keep the grouping intact. You change the grouping, the answers would be different. Let us go ahead and talk about the identity and the inverses of subtraction. Now, in case of addition, the identity was 0. Now let us check out what happens when we take 0 as an identity in case of subtraction. So if I have a upon b minus 0, then the answer would be a upon b. However, if I have 0 minus a upon b, then my answer would be minus a upon b, which tells us that 0 is not an identity for subtraction, which means that there is no identity for subtraction of rational numbers. Now, since there is no identity for subtraction of rational numbers, there would also be no inverse for rational numbers, for subtraction of rational numbers. So the subtractive inverse would also not exist. Now let's go ahead and talk about multiplication of rational numbers. Now multiplication of rational numbers is quite different as compared to addition or subtraction. So let us see first how we do multiplication of rational numbers. Now in this case we are considering them as fractions. So if I have a upon b and I multiply it by c upon d, then my answer would be a multiplied by c upon b multiplied by d. Many students make a mistake in this. They do it exactly like the addition. That is, they make their denominator same and then do the multiplication, which is absolutely incorrect. So if you have to multiply the rational numbers, then we are going to multiply the numerator to the numerator and denominator to the denominator. The detailed video has its link given in the description box. So in case you have queries, please click that link, and if the queries persist, feel free to write in the comments or drop by to the academy. The next thing that we talk about is properties of the properties of multiplication of rational numbers. So the first property that we are going to look at is the closure property. It pretty much makes sense. If you take two rational numbers, you multiply them with each other, then the final answer would also be a rational number. So the rational numbers follow closure property. Let's take a simple example. If I have 3 upon 4 multiplied by say 3 upon 5, the final answer would be 9 upon 20, which itself is a rational number. Let's go ahead to the next property, that is the commutative property, which tells us if you change the order of multiplication, the final answer would remain the same. So let's see if it works or not. So let us take this example. I have 3 upon 4 multiplied by 3 upon 2. The answer would be 15 upon 8. Now, if I reverse the order, I'll get exactly the same answer. Thus, I can say that multiplication of rational numbers is commutative. Now let's go ahead and talk about the associative property. Yes, the same old property where we group them separately and then multiply them. Okay. So the associative property says that if I have A upon B multiplied by C upon D multiplied by E upon F, then it should be equal to A upon B multiplied by C upon D multiplied by E upon F. So let's take a simple example. If I have 1 upon 3 multiplied by 2 upon 3 multiplied by 4 upon 5, and I take this as a group, I'll get it as 2 upon 9 multiplied by 4 upon 5, giving the final answer as 8 upon 45. If I group them separately, that is, I write 1 upon 3 multiplied by 2 upon 3 times 4 upon 5, then I would get it as 1 upon 3 multiplied by 8 upon 15, which would be equal to 8 upon 45. Exactly the same answer. So we say that multiplication of rational numbers follows associative property. Let's go ahead and talk about the multiplicative identity and the multiplicative inverse. So number one is an multiplicative identity, which basically means that if we are multiplying the fraction or the rational number with 1, the final answer remains exactly the same. So if I have A upon B multiplied by 1, it is equal to A upon B, which is also equal to 1 multiplied by A upon B. So the value does not change by multiplying it by 1. That's why 1 is called as the multiplicative identity of a rational number. Now, what happens if, so how do we get the inverse? The inverse of the rational number is going to be its reciprocal. What's a reciprocal? It is basically the given fraction flipped over. That is, the numerator becomes the denominator becomes the numerator. All rational numbers have inverse except the number 0. So this is something very important that you need to keep in your mind when you are finding the inverses of a rational number. So the multiplicative inverse of rational numbers exist except for the number 0. So if I have the number as A upon B, then its multiplicative inverse would be B upon A. So A upon B's multiplicative inverse would be B upon A. If it is minus A upon B, then the multiplicative inverse would be minus B upon A. So now this is a way in which we write the rational numbers in standard forms because we are keeping the negative sign on the numerator. Okay. Now let's go ahead with the next operation that is there, that is division of rational numbers. Now the next property that we have is distributivity of multiplication over addition. Though this property is called as distributivity of multiplication over addition, it is applicable to both addition and subtraction. So let's see how it works. So if I have three rational numbers as A upon B, C upon D and E upon F, then A upon B multiplied by C upon D minus plus E upon F will be equal to A upon B multiplied by C upon D plus A upon B multiplied by E upon F. Same thing would be true if we have a minus sign here. So if we have A upon B multiplied by C upon D minus E upon F, it would be equal to A upon B multiplied by C upon D minus A upon B multiplied by E upon F. So this is called as the distributive property of multiplication over addition. So let us have three rational numbers. We have 3 upon 4 minus 4 upon 5 and 5 upon 6. So if let us first find what we get after 3 upon 4 multiplied by minus 4 upon 5 plus 5 upon 6. So the distributive property tells us that this should be equal to minus, this should be equal to 3 upon 4 multiplied by minus 4 upon 5 plus 3 upon 4 multiplied by 5 upon 6. Now let's solve this side first and the left hand side first, and then we'll solve the right hand side. So it would be 3 upon 4 multiplied by, I do the addition here, I'll have minus 24 upon 20 upon 30 plus 25 upon 30. So that would be equal to 3 upon 4 multiplied by 1 upon 30, giving me 3 upon 120 as my final answer. Now let's see whether the answer matches here. So we have, this would be this side, this first part would be minus 12 upon 20 plus 15 upon 24. So the LCM for this is 20 and 24 is 120. So here 20 needs to be multiplied by 6. So that would be minus 72 divided by 120 plus, now 24 needs to be multiplied by 5. So that would be 75 divided by 120, giving me 3 upon 120. Or we can further write this as 1 upon 40, and this also as 1 upon 40. So this is in the standard form. So if you see in both the cases, we got exactly the same answer. Now we can do exactly the same thing with subtraction and we get the same answer. That's why we say that multiplication of rational numbers is distributive over addition, effectively meaning that if I multiply two rational numbers, I can separate them out like this. Now let's go ahead towards division of rational numbers. So what happens when we divide two rational numbers? So if I have a upon b and I divide it by c upon d, then effectively I multiply it by the reciprocal. So it gives me a upon b multiplied by d upon c. So if I have to divide two rational numbers, all I have to do is I have to divide multiplied by the reciprocal, effectively dividing the numerator by c and the denominator by d. Okay. Now let's go ahead and talk about different properties that are associated with division of rational numbers. The first property that we have is the closure property, which tells us if I take two rational numbers and I divide them, then the final answer would also be a rational number. Now this is slightly tricky because this doesn't happen with 0. So if I take 0 and I divide any number by 0, my final answer is not defined, which means that rational numbers follow the closure property except for the number 0. Now let's go ahead and talk about the next property that is there, that is commutativity, meaning if I take two rational numbers and I do the division, if I swap the positions, what happens? Let's check this out. So if I have 2 upon 3 and I divide it by 3 upon 4, then my answer would be 2 upon 3 multiplied by 4 upon 3. It would be equal to 8 upon 9. On the contrary, if I reverse the order, what happens? I get 3 upon 4 divided by 2 upon 3, giving me my answer as 8 upon 12, and in its simplest form it would be 2 upon 3. So we can clearly see that my left hand side is not equal to my right hand side, telling me that division of rational numbers does not follow commutativity. Now let's go ahead and check out whether it follows associativity or not. So let us first write whether it is associative. So from here we can conclude that a upon b divided by c upon d will not be equal to c upon d divided by a upon b. Okay, so let's go ahead and talk about associativity of rational numbers. Okay, so let us go ahead and talk about associativity of division. So we have A upon B divided by C upon D divided by E upon F. We group them first like this, and then we group them in a different way. That is A upon B divided by C upon D divided by E upon F. Okay, now let us see what we get. So say if I have 2 upon 3 divided by 3 upon 4 divided by 4 upon 5, then it would be 2 upon 3 divided by 3 upon 4 multiplied by 5 upon 4, which should be equal to 2 upon 3 divided by 15 upon 16, which would be 2 upon 3 multiplied by 16 upon 15, giving me the final answer as 32 upon 45. What happens in this case? I have 2 upon 3 divided by 3 upon 4 divided by 4 upon 5. Since I'm grouping these first, it would be 2 upon 3 multiplied by 4 upon 3 divided by 4 upon 5. So it would be 8 upon 9 divided by 4 upon 5. So that would be 8 upon 9 multiplied by 5 upon 4. So that would be 40 divided by 36, or we can say that it is equal to 10 divided by 9. Now we can clearly see that our right hand side is not equal to our left hand side, which tells that division is not associative. That is, division of rational numbers is not associative. Now in rational numbers, in division of rational numbers, the identity does not exist, and since the identity doesn't exist, there is no existence of the inverse of a rational number. So friends, this was all about rational numbers, the properties of rational numbers, and the operations on rational numbers. So friends, that was all about rational numbers. If you found this video interesting, please give us a thumbs up, do share it with your friends, and do subscribe to our channel. This was Dr. Rishi from the Learners Academy. Thank you.